Good morning, students. Now, I am going to share my PPT. Okay, guys. I think now we can able to view this. So, on behalf of Wales School of Maritime Studies, I invite you to attend this Physics IMUCET practice session. So, the very first one here, I am giving the formulas. Since I'm going to take electrostatics, current, electricity. So here I have given the important formulas which will be very important to keep in your memory to solve the numericals and to understand the concepts. And as I said in my above class, that unit and dimension, which will be very important for to pick correct answer in the MCQs. So here, this unit and dimension, generally you have to concentrate the SI unit and the physical quantity and also the dimensions, the rules for the dimension, that is one dimension, two dimensional. So what are all the principles given this, everything I have given in this slide. And next, so guys, as I told already that laws of motion is important. So you have to understand the work, power and energy concepts. So here guys, as you aware of this Newton's law, so all the three Newton's law is very important. So I think many of you very well understand the concepts already. So just regain this conceptual class. Here I am going to give brief detail about this laws. So, Newton's first law, a body will remain less rest until you will get you will give force on this body. So, this first law denotes that the law of inertia, that is moment of inertia, until the external force will hit the body will feel in the rest always. So, if you hit the ball, so just opposite to the direction of the force, it moves. And the second one, that when an external force which is applied to the body of constant mass, the force produces an acceleration. So based on the force, the mass attain the force and it goes to the acceleration. So this particular is directly proportional to the force and also inversely proportional to the mass of the body. So everybody know about the third law, that is equivalent opposite reaction of the force for every action. So, which shows the linear momentum of a body. It defines the product of the mass of the body and also its velocity. So, guys, here we are giving the force by action is F1 and the in turn we will get the reaction, that is minus F2. So, F1 is equal to F2. And now, moving on into my next chapter, that is current electricity. So here, electrical energy is transmitted over large distances at high alternating voltages. So here, what is our question? Which of the following statement is not correct? So guys, you need to concentrate this question because here three statement is correct and one is not correct. So you have to concentrate to pick the not correct answer. Okay. So for this, you have to understand the total concept of the electrical energy transmitted to the long distances. Okay. So here the wrong answer is transmission lines can be made thinner. This is wrong because why this is wrong means this transmission energy over the large distance or long distance at a high alternating voltage, the current flowing through the wire will be low because the given power P is equal to E and I, that is energy and current. So this E RMS into I RMS. So root mean square. RMS means root mean square. Moving on into the next one. So when is the current in a circuit wattless? So here is also guys that if the current in a circuit is wattless means that is and that is the correct answer is when the resistance of the circuit is 0. So here, because the current in a circuit is wattless, so that the resistance is also 0. And next, the quantization of the charge, which indicates that is fraction of the charge of an electron is not possible. Because based on the semiconductor guys, we know very well that electrons takes place the holes. That is, it occupies the holes. So we can transfer the electron from lower electronic state to higher electronic state. But we cannot calculate the fraction of the electron. We can calculate 1 electron, 2 electron. Okay. So it is impossible. And next one, if the charges of the charged body are very small compared to the distance between them, so we can treat them as a point charge. Because see, one point to another point or one end to another end, we can say as A, B. So that is the point charges. That is the size of the charged body is very small. So compared to the distance, we can treat it as a point charge. Next, guys. So here the two properties of the material of the wire which is used for suspension of the coil in a moving coil galvanometer. So what are all the two properties guys? That is the two properties of the material of the wire which is used for suspension of the coil in a moving coil galvanometer is one is non-brittle conductor, another one is restoring torque per unit twist. So this is the two important properties. Moving on into next one. Guys, this is the numerical based question. So here, what is that given problem? An electric dipole with a dipole moment 4 into 10 power minus 9 cm is aligned at 30 degree, that is theta. So, in the uniform electric field of magnitude is 5 into 10 power 4 Newton Coulomb. So, what they are asking us, calculate the magnitude of the torque. So, here you need to find what are all the given data they have given here. So, in the OMR sheet, take the rough sheet, rough space. So, here you have to write the given data at least that is P is equal to 4 into 10 power minus 9 and theta is 30 degree and E electric field magnitude is 5. So now what they are asking us to do, magnitude of the torque. Okay, so torque is equal to PE sine theta. So here substitute that simple values given in the very simple formula and do the calculation. You will get 10 power minus 4 Newton meter. Very simple problem only guys. So for this, you need to concentrate the formulas. What formulas applicable for this problem? That's all. Okay. And next one, that is the force between 2 point charges change if the dielectric constant of the medium in which they are kept as increased. So we know dielectric constant K is equal to Fv by Fm. So here V is vacuum and M is the point charge between two medium. So They have asked us to find the force of the medium. So Fm is equal to Fv divided by K. So from the above expression, we know very well that K will get increased, force of the medium will get decreased. And next one, define 1 coulomb. Guys, I told you already that unit and dimensions, we have to know all the parameter with the definition. And this is for 1 coulomb is the charge on your body is said to be 1 coulomb means if it experiences a force of repulsion or otherwise attraction which is equal to charge when they are separated by a distance of 1 meter. Okay, guys. Now, the next question is to convert galvanometer into an ammeter. So here, guys, we know very well we have to connect the galvanometer series and parallel. So here the question is how to convert the galvanometer into an ammeter by connecting in which mode. So that is low resistance in parallel. Why low resistance in parallel means because low resistant which is also known as the shunt resistant which is connected in parallel to the galvanometer so that the value of shunt is also adjusted that the mode of current passes through the shunt so that we can convert galvanometer into an ammeter. And next question, guys. If a charged particle at rest which experiences no electromagnetic force, then it is called as the magnetic field may or may not be zero. That is, the charged particle which is moving parallel to the application of the direction of magnetic field, so it experiences definitely no force. So that the charged particle in an electric field, whatever the direction it may be moving, it experiences no electromagnetic force. So the next one. So here guys, this is also very simple numerical. That is the two charges they have given and these two charges are in a straight line. So one point, let us assume A and B another point. So the two charge of the point is 2 mu c in A minus 2 mu c in B. And the distance between these 2 points is 6 centimeter. Okay. So now what they asking us, that means identify the equipotential surface on the system. So here 2 mu c, another one is minus 2 mu c. So equipotential surface of a plane is the total potential is zero everywhere. That is because this plane is normal to the line AB. So the line AB is located in the midpoint of line AB because the magnitude of the charge is also same. 2 because in point A it is 2 nu c, in point B it is minus 2 nu c. So what is the direction of the electric field at every point? So the direction of the electric field at every point of the surface is normal to the plane of the direction of AB. And next, a low voltage supply from which one needs high current, it must have very low internal resistance. So according to our Ohm's law, we know very well that V is equal to IR. So I is current and R is the internal resistance. So we have to rearrange this, that is I is equal to V by R. So this is the diagrammatic representation of the question, that is a steady current flows in a network as shown in the figure. Okay, it is like a diamond shaped circuit network connection. What will be the magnetic field at the center of the network? So guys, you need to concentrate that they are asking the magnetic field only in the center of the circuit, means within the closed surface, that is P, Q or S. They are not asking the outside surface. So what we have to concentrate this, one is in the always in the current and electricity and also in the ray optics. We have to know that why we are giving this arrow marks. Why we are giving arrow mark? Because it denotes the flow of direction of the electric field in current electricity and flow of direction of the light in the ray optics. Okay. So for these two chapters, we use the arrow mark definitely. So in this diagram, PQR, one direction of current is moving and PSR is another direction of current is moving. So here PQR is equal to PRS. That means the magnetic field at the center of the network is 0 because the magnetic field due to PQR is equal to and opposite to the PSR. And next, like this is also one question numerical based on the magnitude, that is 1 coulomb is distance, 1 coulomb of the charge placed at the distance of 1 meter. So another charge of the same magnitude. So we can go for the answers. See guys, here the answer is based on the only this 9 and 10. And you have to be aware of the 10 power minus or plus to pick the right answer. For the formula for this is force is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So 1 coulomb and 1 meter. So substitute this, we will get the right answer is 9 into 10 power 9 Newton. And next also graphical representation numerical. That is what is the work done which is moving into MUSE point charge from one corner A to another corner B of a square. So guys, this is a square A, B, C, D. At 10 MUSE charge exists at the center. So we know VA is equal to VB. So that work done is equal to 0 since it is the square shape. And next guys, this question is for Van de Graaff type generator. So what they are asking, they have to uh, they're asking us to find the minimum radius. So what are all the given values? That is the generator spherical metal shell, which is having 15 into 10 power 6 volts of electrode. The dielectric strength is 5 into 10 power 7. So find the minimum radius. So I have to write the given values. V is equal to 15 into 10 power 6. Like that electric strength, dielectric strength 5. And the electric field intensity E is equal to 5 into 10 power 7. So find minimum radius R is equal to V by E. So substitute V is 15, E is 5. So R is equal to 0.3 meter. Convert this is 30 centimeter. That's all. Very simple problem, guys. And next, see guys, this is very important concept based question. Okay. Now, VI graph, okay, that is voltage current graph for a metallic wire at two different temperature, which is shown in the figure. So, what are all the two different temperature? T1 and T2. And what is the meaning for the dotted line here? So, they have given two temperatures, T1 and T2. Dotted line denotes the slope. Okay, the slope of this temperature. So, which temperature is very high? Whether it is T1 and T2. Always to solve this problem or to solve this concept, we can understand the thermodynamics law. So, what is the thermodynamics law? Denotes as del T is equal to T2 minus T1. T2 is final temperature, T1 is initial temperature. So, always T2 is high than T1 because once initial temperature the process is going on, it take hours or minutes to reaches the final temperature. So final temperature also will increase based on time increase. So T2 is always higher than T1. So here we have to give, that means the temperature T2 is high because T1 is the small slope. That's all. Okay, moving on into the next topic, that is semiconductor devices and its application. Such a very super and wonderful topic, semiconductor devices. Because nowadays we are using LEDs, LCDs, your mobile phone, smartphone, iPhone, okay, all our desktops, laptops, okay, and TV, screen, touch screen, everything is based on this semiconductor device application only. The dramatic innovation in the research gives, these are all the smart electronic devices for our current life applications. So we know, guys. One minute. So the semiconductor electronics means the material which it produce the conduct the electricity, which is called as semiconductors. So what is the name of the two semiconductor metals? You know very well that it is germanium and silicon. So based on this, we can go for the types of semiconductor. One is intrinsic semiconductor, another is extrinsic semiconductor. So the intrinsic semiconductor is pure form of semiconductor. That is germanium and silicon. So which have equal number of holes and conducting electron, and the net charge in the lattice is also zero. An extrinsic semiconductor is impure form of semiconductor. That means we have to add some of the doping metals in this pure form to get the extrinsic semiconductor. So this extrinsic semiconductor we can go for into two types, that is p-type semiconductor and n-type semiconductor. Now, I think you can able to see this slide. That is, it consists of the semiconductor doping. So here, this blue color shows the p-type semiconductor and this brown color shows the n-type semiconductor. And between this is called as the depletion region or depletion layer. So in this diagram, that is the unbonded free electron donated the, which it has to be donated by the pentavalent, so that it is 5 valency atom created. So this, in this diagram, guys, that is this p-type, n-type diode will get due to the configuration of this semiconductor only. And energy band gap in the various type of materials. So these materials, guys, we can classify into insulator, semiconductor, and conductor. So this insulator, semiconductor, and conductor, we will get energy band gap, that is conduction band and valence band. So always higher electric state is conduction band and lower energy state is valence band. So the energy gap between the conduction band and valence band is called as the energy band gap, EG. That is, high energy band gap is insulator and the medium energy band gap is semiconductor, and the lower energy band gap which is filled very low, that is called as the conductor. So next, the draw the graph which is showing the variation of conductivity with temperature for a metallic conductor. That is, to conduct the variation of conductivity, we can take temperature in x-axis and sigma in the y-axis. And this is the two wires AB, which are made up of the same metal and same length. Okay, guys. So their area of cross section is a ratio is 2:1. So what they are asking is, what is the ratio of current flowing A and B? So we have to go for the formula I is equal to V by R and R is always less than 1 by A. So we can calculate the area of cross section is 2 is to 1. Then the ratio of current flowing in AB will be 1 is to 2. State one condition for maximum current to be drawn from the cell. That is I is equal to E divided by capital R plus small r. That is internal resistance must be 0. And next one guys, here it shows the figure that is pure form of semiconductor S in series with a variable resistor R and a source of constant voltage V. So would you increase and decrease the value of R to keep the reading of ammeter A constant? Now, when the semiconductor S is heated, so what we will get? That is, on increasing the temperature, the resistance of the semiconductor will get decreased. So, to increase the temperature, the semiconductor S will get heated. So, to maintain the constant current in ammeter, the total resistance of the circuit should remain unchanged so that only we can increase. So, therefore, the value of R has to be increased. And what are ohmic and non-ohmic resistors? Give one example for each. So, ohmic resistors are the resistors. We know very well that it must to obey Ohm's law. For example, it is metals. But non-ohmic resistors means it doesn't obey the Ohm's law. Example, it is semiconductor diode and transistor. State two factors by which the voltage sensitivity of the moving coil galvanometer can be increased. Means voltage sensitivity, this is the formula, and it can be increased by increasing B using powerful magnet and decreasing K by using faster ground strips. And next question is, an iron bar is heated. An iron bar is heated to 1000 degrees Celsius, 2000 degrees Celsius, and then cooled in a magnetic free space. Will it retain its magnetism? Means that is, a Curie temperature of iron is 770 degrees Celsius. When it is heated to a very high temperature, magnetism of iron is lost. So, it does not retain its magnetism after heating 770 degrees Celsius. And next question, guys, that is state true or false. That is, the cyclotron is a device which accelerates the uncharged particle. It is false because cyclotron is a device which is used to accelerate only the positive charged particles. Why we are using cyclotron? Because we are using the cyclotron to accelerate the positively charged particles. It is a device for this application only. Next, the magnetic moment of a current I carrying a circular coil radius R in a number of turns N, which is weight R square. Next, what happens to the inductive reactance when the frequency of AC supply is increased? So, AC supply increase means automatically frequency also will get increased. Okay, guys. So, here the answer is A, increases. Next, a metallic wire coil is stationary in a non-uniform magnetic field. So, what is the EMF induced in the coil? That is, no EMF is induced in the coil. Why means there is no charge in the magnetic flux linked with the secondary coil. That's all. And next, what is meant by Weber? So, Weber means it is a SI unit of magnetic flux. and linking of the circuit of one turn, it would produce it in an electromotive force of 1 volt if it were reduced to 0 at a uniform rate in 1 second. This is called the Weber. And next, magnet, which is moved in a direction indicated by an arrow between two coils AB and suggests the direction of the current in each coil. So here, that is the direction of the current in each coil, it is in the anti-clockwise direction. So that is anti-clockwise direction in the sense which is seen from the AB and CD. So D side of the coil only we will get. So that it is the anti-clockwise direction. Therefore, the direction of current in a coil. Okay, guys, thank you. We will continue in the next class. So, guys, one important task is that if you have any queries or question or any doubt, please kindly ask me to clear your doubts. Any doubts, guys? Thank you, guys.